Another major point of discussion in Section 2.1, and we'll actually spend a bit of time on it, is this idea of symmetry. Very important role, does a lot of things in mathematics, it does a lot of things in real life, including helping us build what we call ciphers to listen in on people's conversation or to take the fuzziness out of a picture. Believe it or not, at its core, it all comes down to this simple idea of symmetry. So very, very important. First of all, what is symmetry? Well, that's basically when we have an image on one side, right, and it kind of matches an image on another. All right. As a matter of fact, symmetry is very pleasing to the eye. Both in art, all right, and even visually. The more symmetric something is, the more we're inclined to like it or to be interested in it, whatever the case might be. But it turns out that in math, there's actually two types of symmetries that can occur. One of those is that we are symmetric about a line. And that's kind of what I did there. I have an image on the same side, but it's symmetric. It's a mirror image, if you would, right, through some line. Parabolas, right? We've done parabolas before, but when I graph a parabola, that is symmetric about a line. We also have some ellipses that can be, kind of bent over or rotated. This has lots of symmetries about line, right? That shape is symmetric about that line, right? Mirror image. It's symmetric about that line, mirror image. So one of our symmetries is about lines. And then another one is being symmetric about a point. And what that basically means is here's a point. To be symmetric to it, let me put a little X here. That means if I basically rotate myself 180 degrees, if you would, right, then I will have a matching point on the other side of this line. So it's about rotating ourselves 180 degrees. So if I go through a half rotation about the point of interest, we are basically symmetric with it. What some people like to do, especially when I start putting a x-axis to this, is they think of doing a slap, right? Slap up and down, slap left and right, and I should have my mirror image. But it's really about a 180 degree, a half rotation about the point to be symmetric. So with that in mind, right, let's go ahead and take a look at the type of symmetries that we're going to talk about in this class. One of them is to be symmetric about the x-axis. Now that's a line symmetry, right, because the x-axis is a line. So let's concentrate on that. Let's take a look at the four graphs here, right? Which one is symmetric with the x-axis? And hopefully you guys are thinking this one, right? Because here's my x-axis, and it's a mirror image along that line. So this guy is symmetric about the x-axis. The picture above the x-axis matches the picture below the x-axis. The mirror images of each other across that line. All right. The y-axis is another symmetry that we worry about. It is also a line symmetry. We're symmetric about a line. So let me pause and let you look at the graphs I have there, and which one would be symmetric about the y-axis. All right, and I'm hoping you're pointing to this one, or you're thinking about that one over here. Here's my y-axis, right, and the image on this side of the y-axis, if I folded the paper, if you would, right, I get that picture over there. So mirror images of each other. So that one is symmetric about the y-axis. What about the origin? Right, well again, take your image and go through a half rotation, or what you'll see is a double flap. Right, so if we take a look, right, kind of we're down to these two right here, right, there's the origin. If I was to rotate this picture about the origin, right, I can kind of think, you can see that's not going to be symmetric. It's going to be a completely different shape, right? However, this one, if we were to rotate this 180 degrees, we'd be down here. And this is why some students like the double slap, all right? If I would basically mirror image across the x and then mirror image across the y, I'm right here, right? Mirror image across the x, mirror image across the y, I'm right there. So these data points here and these data points here, you can think of it as a double flip right through the x and the y axis, or what's really going on is we're rotating 180 degrees and getting the same picture. So that one is symmetric about the origin. This one, by default, because we've handled everything, that's not symmetric with anybody, right? Clearly it's not symmetric with the x-axis. Clearly it's not symmetric with the y-axis. And again, if I did the double flip, right, this would be here, and then I'd actually have a graph here and, you know, up here somewhere. So it's definitely not symmetric with anything. Many of the things we study have no symmetries at all, all right? But we're going to be focusing on this particular chapter, symmetries about the x-axis, symmetries about the y-axis, symmetries about the origin. And so one of the first things we do to kind of get familiar with this is to, you know, kind of play around with it, point to point and graph to graph. So here's some homework-like problems, if you would. So I'm going to start off. Let me go ahead and sketch the data point. Right, we're at -2, 1, 2, 3. So there's my data point, -2, 3. Where would I plot a point? Right, label and plot a point that is symmetric to this point through the x-axis. So again, it's a mirror image. So I would probably have to go down 3, and so we're talking about -2, -3 right there. So there's the mirror image along the x-axis. So there is your answer for A. Let me redraw this. 1, 2, 1, 2, 3. So there's -2, 3. This time we're symmetric about the y-axis. So our y-axis is the mirror image. So basically that's got to be right here. So that's going to give us the ordered pair 2, 3. All right. So there'd be the point that's the mirror image of the point that's given. And then of course the next one, right, -2, 1, 2, 3, 1, 2, 3, 1, 2, right? So here's our point, -2, 3. It's kind of hard to see that rotation, I get it. So here's where that double flip is going to occur, right? If I flip this through the x-axis, I'm down here. If I flip it through the y-axis, I'm right there. There's our point. It's actually, it looks like it's at 2, -3. That's the point that is symmetric about the origin of the point that's given. And now that you actually have plotted it, you can kind of see if I did a half turn, right, this point would basically move down to there. Okay, so there's your symmetries point by point. All right, symmetric about the x-axis, symmetric about the y-axis, symmetric about the origin. All right, and more on this later. Really important terminology. But we're running out of time, so let's go ahead and take a look at the next example. Right now what I'm doing is I'm not giving you a point, I'm actually giving you a graph. Right? This graph's not symmetric with anything right now, right? But I want us to complete the graph so that it is symmetric with something, in this case the x-axis. So here's my x-axis, right? And we're supposed to be a mirror image across the x-axis. So that data point will go here, that data point will go here. Let's see if we can find another. That data point would go about here. So if I had to complete the graph, right, there would be the completion of the graph making it symmetric with the x-axis. All right. The next one, I want this graph to be symmetric about the y-axis. So whatever I see over here gets flipped, and whatever I see over here gets flipped. So this point will move over here. That point, since it's on the x-axis, will stay. And how about we take this point here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We'll flip to over there. So basically what I have in blue, right, there would be the graph causing the symmetry about the y-axis. And especially now that I graphed it, hopefully you can clearly see we've got a mirror image across that. Okay, so that is mirror to that, and that's mirror to that. We're mirrored across the y-axis. Origin, again, kind of hard to see the rotating around, but how about we just kind of flip some points. Again, if I do a double flip here, if I rotate this around 180 degrees, it's going to move to here. If I move this point to 180 degrees, it's going to move to there. So you can almost kind of see it coming. But if you want another data point, like this one here, I'm going to first flip it through the x-axis, and then second, flip it around the y-axis. So there's your double flip action if you're having trouble seeing the rotation. And so there would be the extension of that graph, rotated 180 degrees, and we now have symmetry about the point, which is the origin. So there's basically how you do that, both by point and graph by graph, and what they mean, what their meaning are, right? So symmetry about the x-axis mirror image about the line that represents the x-axis, symmetry about the y-axis, a mirror image about the y-axis. The harder one is the origin, right? It's either a double flip action or you're literally rotating 180 degrees around the origin. Much more to this. We now need to, everything's been visual. We need to build an algebraic approach to all this. So that's what we'll do in some upcoming videos.